Okay, so my talk today is on progressive web applications, or PWA for abbreviation. So who am I? My name is Robert Acock. I'm from Oxford in England. On CPAN, you may have seen me as Our Nation. I have 46 open source modules. I understand that all of them are useful. Some of them maybe. This is my open plan office. It's very nice. I have nice views, and I don't have people peering over my shoulder. So it's nice. Before I start, I just want to say a quick thanks to some people. Dan Thomas, because he hired me when I couldn't even SSH into a server. Robert, David, Aaron, and Mark, because they always answered my dumb questions, and they still do. Robert Brown, because he hired me to do JS when I couldn't write JS. Arba, which is in the room. And Hans, because they hired me for a Dutch pill shop, and I didn't speak a word of Dutch. But I lived in Amsterdam for 4 months, which was quite cool. And then Anselmo and Andrew, because they gave me my job I currently have, which lets me work fully remote and travel basically for the last 2.5 years. Anyway, so what I'm going to talk about today is PWA. This is a screenshot from Google. It uses fancy business words, so you can sell it to your business. But in theory, it's reliable because it loads instantly and it allows you to build your own offline experience. It's fast because you retrieve your resources from the cache, but you have the cache that you control yourself, and it's not what the browser decides to cache. And it's engaging because you can install this natively on any device that is running Chrome, more or less. So your phone, for example, I can install it on my Mac into the applications folder. It's nice, I can launch it, and it runs in a headless Chrome window. So the dinosaur page is this. I'm sure you've all seen it when you've lost network connectivity, or you visit a website and then you get this, and you're like, oh, what's happened? I have no connection to the internet. So this is what we're trying to solve, basically, or Google were. And that's why progressive web applications come around, and service workers, and the cache. So an overview of what I'm going to talk about today is just a subset of this. And it's mainly how to write a service worker and how to intervene or use the cache API. When I say service worker, what that lets you do is cache your resources, your endpoints. So this includes CSS, JS, images, your HTML, if you have an API, your JSON responses, SOAP, whatever you would like. But you can always fall back on API requests. So if you've got dynamic websites that need up-to-date data, then you can always just use the default fetch mechanism. What I like the most about this is it's all vanilla JavaScript. You can run it in production because you can write this and it's not going to break in IE 10. Your code will still run because it's something that will only work in modern browsers, and you can write it in a way that allows you to only identify the browser that can run this code. So that's what I like most about it. And its longevity. In 10 years' time, I still know vanilla JavaScript. So I think it's still going to be there. So what is a service worker? Fundamentally, it's just a script. We all know how to write a JavaScript file, I hope, and that's as simple as this. It's no rocket science there. But let's talk a bit about the cache API and what that provides. It's a mechanism that allows you to cache requests and responses in like an object. It also it's persistent, so it's stored on your hard drive or your and it's only limited by that and what that's allocated to Chrome or the browser that it's using. And it's also shared, so the cache isn't just accessible by the service worker. You can also use this in your tabs, so in your application code. And the really good thing about that is that you can do cool things like if you've got an API that's going to take 10 seconds to return a response, you can use the cache, render the view, get the new data, and then update your view with the new data. So it's useful in that sense. The only thing it sucks is that it doesn't natively handle post requests. But you can work around this by doing various things. But we're not going to talk too much about that. Use your imagination, like I say. So a general life cycle of a service worker is the following. Again, this is taken from Google, but no service worker is when the end user just visits your website for the first time. You have some JavaScript code. Am I in a modern browser? Yes or no. If I am, I install my service worker. This then has several events involved inside of it. The three I use most is install, activate, and then fetch. And this is basically what I'm going to talk about next. But there's an idle state is basically when you're waiting for requests. Stop, the service worker won't be running all the time, so if you close your browser, it might be stopped, and then when you reopen it, activate event will run when you revisit the website, so it's nice. And also there's a bunch of other things, but we'll talk about that another time maybe. So this is the basic code for an install. We have some variables at the top, and I'll just go through these quickly. So this is your cache name, so every time you release to production, let's say, you're going to want to update your cache name. Because what this will then do is refresh the data or refresh the resources the next time the end client or the end user visits your site. You have an offline file, so this is going to be your default response. Most of the time, perhaps it's going to be HTML, so you override the default dinosaur page, but you might choose to have it as JSON. It's up to you. Then we list a bunch of files to cache, and this is pre-caching. So this is when you, in the install event, so when the user first visits the site, these resources are fetched and cached. They don't have to be on the page. These can be your entire application. You can put in an array, every endpoint, and you can pre-cache it all, and then your website will totally work offline without a network. But the actual event handler is just vanilla JavaScript. You've seen all this before, probably document.add event listener. Here's South being the service worker. And this has an install event, and it accepts a function. We have then wait until. You might not have seen this before if you've not seen promises. But what this is doing, it expects the promise to be returned from the code that's enclosed. But what I do here is I use caches, which is the caches API. I open it with my cache name, so you can have multiple caches for a domain with different names if you like, but in this example we have one. And then once I have my cache, so it's an object, I then say I want to add all of these files that are in my array, and then this then goes off to the network. It fetches these, and then caches it, and every request from then on will be used as long as you write the right fetch handler. So the next state is activate. Activate for me usually includes code which destroys the cache. So I've updated my cache name. I want to clear that, and because I've got a new release in production, I've got a new cache name, version 2, and I want it to refetch all of my resources so I know they're up to date, and I don't have to version all my JavaScript files, and I don't have to rely on the end user hard refreshing because it just magically works. So again, it's just a simple add event listener, this time with activate. I'm waiting for a promise to be returned. I use caches.keys, which then returns all of my caches names. Again, in this example, we only have one. I do a little promise just for the sake of it. You don't need to write it like that. But then I map the array to get the keys out of it, and then I go, does this key equal my cache name variable? If it does not, then just delete all of my keys. And the last South client's claim is just making sure that this applies to all my open browser windows. So, because again, I didn't say this, but a service worker works below, so it's shared across all tabs, or the entire browser instance. It's not a single one-to-one per tab. Then we have the event handler. This can get crazy as you like. There's lots of ways to implement this. There's more than one way to do it. But what we're doing here is very simple. So we're only going to modify the request process if the past URL exists in our caches. So the files to cache array that we defined at the top, only if that then exists, so index of, we respond with. Respond with is a promise based as well, but it expects a promise that returns a response. So you can either, like what I do here is I go caches.match, I check the caches object, do I have my request URL? Then yes, I do, then return a response. If I don't, if response is undef, then I default to use the API, or the network, I should say. So it's the default fetch handler. All other requests, every request will run through this code, but any other requests will just default to use the normal fetch process. I don't have to deal with that, it just works. So then from your application side, this is the code I was referring to that you want to check whether your browser is modern. The easiest way to do that is just doing an if statement. So does my client support service worker in the navigator? Yes or no? If it does, fantastic. And then what you can do is, here I'm checking whether I have a registration already, so whether there's already a service worker installed. So I'm going, get all of my service workers that are for this domain. Again, you can have multiple service workers. You don't have to have one, you can have 10. But in this sense, we only want one, so if this does not exist, then we register. Ooh. And that's as simple as that. That will then call or start my service worker in the background, and again, it's shared. I just do it's a promise again, so I just go then. So in your console, you'll get a nice message saying, yeah, it worked. You can have a catch as well if you like. But okay, so I showed you a very simple fetch, but sometimes you want offline to work, and that was what the offline file was for. So what we can do after, so okay, the first one doesn't respond, so let's do a fallback, and what we're doing here is we're going to try and fetch from the network. If that fails, then I want to do something else. This line. It's important to understand that a 500 request or a default HTTP request is not a fail. A fail is when I've lost network connectivity. This is the only time that this will run or that will be caught. And again, okay, for me personally, I have maybe, if I have a multi-page application, I have HTML requests, but inside of that I might have API requests. And I can identify those by the requested with header. And I can say, okay, I've got a native Ajax request here. I don't want to return HTML because that's going to make my JavaScript go kaput, like, yeah, die. I want it to still work and everything to run afterwards. So what I do is I return a nice JSON response. And then from that, you can just give a little notification saying, please try again later, or error, you've got no network. But it's not going to break my application code. If, however, they are trying to request HTML, then I want to default to my HTML page, which is an override of the dinosaur, and it can be much nicer, like customized for your client or your customer. You know, like it's up to you. You can do what you like. So then installing natively, which is something I think really cool, and it's the emphasis on that. And it's so easy that I don't understand why all of you do not already do this. All it is a manifest.json. It's a JSON file that provides information about your application. This allows it to be installed on your phone. It doesn't matter. It's just JavaScript, HTML. It launches like a native application-ish. And yeah, it's cool. And like, there's some useful options here that you can specify. So like the name of your application. Maybe you have a really long name. It's not going to fit on your phone, so you give a short name. Icons, because there's like 100 devices. They all have different sizes. Your array could be very long. Your start URL, which is where you're going to launch your application from. The display, there's several options. I tend to use standalone, but it's best for you to explore these yourself. Background color is like a splash screen, so when you're launching from your phone, for example, maybe the resources aren't going to be there straight away. You might have hundreds, it's up to you, or a long file, a CSS, like Bootstrap. What this does is just loads of splash screen with the icon, and that's the background color you can define. The theme color is the wrapper around based on which display you set. And then there's a bunch of other things. Some of them are still semi-supported, but over time they might become more useful. For example, like the preferred related application stuff. If you've got a native application, you might want to redirect your user to this rather than installing the web application. So it's useful in that sense. So this is what the manifest.json looks like. And all you need to do is declare this file, stick it somewhere, and then add a link to it. And from that, it's like magic. You get this like nice little user interface, which is from left to right. You see at the bottom we have the install application button. You press that. You say yes, I agree. Then it installs into your application, so you can click it and launched. And there's slight changes, and depending on which display you use, it looks slightly differently. But I think it's really neat. Like, I like this. This is something. It's like a free web application today, or a free mobile application. So it's cool. And my clients like this. So But anyway, I'd done this talk for the first time at Amsterdam.pm like last month, and I traveled 326 miles, not 6 miles to get here. So I went a long way, out of my way to go there. I used to live in Amsterdam, so I know the people are very friendly and open to speaking English. But I did it in front of 5 people, and one of them was Tux. And Tux said to me, "Where is the Perl? I am so lost right now. Like, this is JavaScript. I have JavaScript disabled on my browser. So what can you do?" So from this, I built a module which is called Progressive Web Applications. Yeah, and it's free for you now. And all you have to, this is the synopsis basically from CPAN. And the only cool thing really is icons, because I was like, I don't want to do this myself, like randomly generate them. So I can just say I want this one file and I want it in every size possible. And from that I can magically include this in my manifest, and it does nice cool things. And I went too fast. So I say root, this is the root of my application, so from where the script is running. This is say for Catalyst script, I'm in the home directory. All of my resources are /root. Part is if you've got like a proxy. Yeah, I'm going quick. If you've got like a proxy, which I do in most of my applications, so it's defined by a path and everything's after it, then you want to include this because your file system doesn't know that already. Apache, your config knows that. Then you have your manifest, which I've just talked about, and it's just key values pretty much. There is some additional logic, like I said, with the icons. You can do other things like give it a subroutine, or code reference, I should say. And then you have params again. This is a very simple example. And then all I do is I go pwa compile, and it gives me a manifest.json, it gives me a pwa.js, which is the custom logic to check whether I'm in a modern browser, and it also gives me a service worker. The default is general, and I have 4 templates at the moment. Offline only is basically just giving you a page to default over the dinosaur page. Pre-cache endpoint is lets you use an API call inside of your install event that will then retrieve from an API a list of resources for you to cache in cases if you would want to do that. General is implementing some more complicated caching logic. So instead of just defaulting offline response or giving every file, you might want to progressively cache your data. So the first thing is pre-caching, cache work, then network is the pre-cache. Network, then cache is when you fetch from the network every time. Unless you're offline, then it defaults back to use the cache. So you get a nicer offline experience in my opinion. General deferred is built because I'm one of those people that really hate it when I visit a website and I see boom, pop up saying, "Would you like push notifications?" No. So it's the same with progressive, like you saw on the mobile. It gives you the banner. It's like, I would much rather I scroll through the website. For example, I use this, and I'm going to show this in a minute, but I use it on my logging screen. I have a little button. When they're logging in, it just asks them whether they would like to install this natively or as a progressive web application. It's up to them. It's not forced. But the main idea with this is, like I was saying at the beginning, there's more than one way to implement one of these. And it's very custom to your company, the way you've built your software. Sometimes, okay, my template will work if it's just a static website, but if you've got really complicated dynamic stuff, or if you want to use more features like the web push API, for example, then you're going to want to write your own, or I might write my own at some point, and I'll give it to you for free. But at the moment, it's still a working process. But feel free, and it's as simple as this. The green dot is basically you insert your JavaScript. The important thing is I wrote my own templating thing, and you should every variable you use, really you should use required, otherwise it's going to do weird things if you don't set it. I have an idea about that as well. But. So this is just a quick example of how I use this. I have a web application, and I have 3 web applications that are in Docker and they're separate. But I only wanted one serverless worker, and I wanted to have one progressive web application because all of them are interlinked within each other. So I didn't want to do this multiple times, but I'm going too fast. But this is showing me generating manifests for dev, prod, simulation, and test. What I do is my manifest file is in a ts-favicon- whichever environment. Inside of my application, I have some logic using n to check which environment I'm in, and it includes the right manifest inside of my HTML. But then I clear my manifest because I don't want my service worker to live in these directories. I want my service worker to work at root. But again, this is, so I'm saying which scope I'm in, which is payment. I have my install button, which is on my logging screen. This won't error if it doesn't exist. This will just, okay, it doesn't exist. I'm going to continue. I declare my cache name because I version that. I have my offline HTML because it's this application's multi-page, and there's lots of variables involved, so I don't want to cache everything. But then what's cool is, this is what I was saying, I can use a subroutine to pick up my files to cache. I have two web UIs in the free applications, which is dashboard and console. And what I'm doing basically is including all of my CSS, JS, and PNG images within the directories, and I iterate. That's what this does. You can look at the code and, okay, I'm almost finished. But it's quite nice, and then I just compile, and that compiles into my dashboard application at root. Then this is what I was coming back to, is that if you've got a really simple application, you might not want to do any of that. So I wrote a command line application to do this for you, and it gives you steps, and you just pass it arguments from where you are. You write literally PWE. It's quite self-documented, I hope. If anyone's tried it, I don't know, probably not. But it's cool. I like it. It was fun to write, so I did it. The end. I think I'm out of time, so no questions. Yes. Catch me outside.